So, hello everybody. I hope you can all hear me fine. Hey, Martijn.
Hey, Filippos.
Hey, hello. So, hey, Ollie, how are you?
Very good. How are you?
Lisa, everybody's joining in. Love it.
Hello.
Hello.
Hey, guys.
So, for the 493 people watching us right now, this is for the next 45 minutes, 40 minutes. Hello, Daniëlle.
Daniëlle, hello.
Hi. So, next about 40 minutes, we'll get the chance to speak about automotive, more specifically the challenges and the opportunities of additive manufacturing within automotive. As you can see in the panel, we are joined by Lisa. Now, guys, I will attempt to pronounce all your names. I am apologizing in advance because I'm pretty sure I'm going to butcher some of them. I've written them down, but just making sure. So we're joined by Lisa Widmann, Business Development Manager at Ultimaker. Dr. Ollie Bröker, Head of Business Development at trinckle 3D.
Hi.
Daniëlle, I'll try my best. Daniëlle I can't do it. Glasbergen-Benning, I apologize. Application Development Specialist of DSM. And Martijn, Joris, co-founder of Twikit. Guys, I think before we jump into the subject of AM in automotive, it would be great if we get a short introduction, a 1 minute, I guess, introduction from each of you about yourselves. Daniëlle, I guess we could start from you and then work our way around.
So my name is Daniëlle Glasbergen-Benning. I work for DSM Additive Manufacturing as an application development specialist, and I have a background in polymer mechanics.
Dr. Ollie?
Yeah, so my name is Ole Bröker. I'm head of business development at trinckle. I have a background in business, let's be precise, industrial marketing, where I did my PhD, and I now work for 6 years at trinckle, a software company based in Berlin.
Thank you. Martijn?
Hi all, my name is Martijn Joris. I'm a co-founder CEO of Twikit. I have a background in product development, and I think basically working in the 3D printing industry for close to 15 years now.
Perfect. And Lisa?
Hey, I'm a business development manager at Ultimaker for the DACH region since September 2018, in the additive market since 2011, and my background is economical studies. Yes.
Perfect. Thanks so much. What I would recommend, guys, I think let's jump right into the subject of today's panel. And in the meantime, for all of you attending right now, I would highly recommend we use the Q&A box for any questions you might have, because it will be great to utilize the power of the professionals we have joining us today to answer as many of them as possible. So feel free to use the Q&A. I guess let's start, before we go into the opportunities of automotive, let's start with what sort of challenges the industry is facing. In the same format, Daniëlle, would you like to start?
Sure. What we've seen from the DSM point of view with companies in the automotive, what the challenges are, is that cars are becoming more electric. So cars becoming more like your phone. So therefore the requirements of the material seems to change. So flame retardancy becomes a big one, specifically when it comes into contact with batteries. And next to that, you have your classic motorcycles, motor vehicles, sorry. If you have a classic car, the emissions, and you still want to drive that car, you need to adjust the car. So.
Fair enough. Ollie, from your perspective?
What I think is really important there, or the biggest challenges we see in our daily business, is that we have to change quite a lot of processes. We are talking here about production processes, but also the whole infrastructure in the back, which has to be changed. So this is not only about the production technology itself and getting all the processes certified and tight and running, but also changing the whole processes within the organization of the automotive world. And for us as a software company, for instance, that means a lot of challenges getting the right fit into the overall infrastructure in the IT of the automotive, but also for the automotive itself, it means that they have to reorganize a lot of things. For instance, if we talk about using additive for customization purposes, that for sure drives a big challenge for the companies to go away from what they have learned in the past, creating for ages and ages a tight system which is meant for standardization and high volume production. And now we're going backwards, so to say, in the history, and go closer a little bit to lower volume production. So there is a lot of hurdles for the automotives to overcome to get those business models going in the additive world.
I see. Thank you very much. By the way, needless to say, for the rest of the panel, if you feel like jumping in the conversation at some point, by all means, feel free to do so. We don't need to keep order at everything. But for now, Martin, if you want to continue, that would be great.
Yeah, sure. Yeah, I think following on what is already shared, automotive companies are big organizations who have a lot of innovation battles to take now. We have the autonomous driving, we have shared cars, we have electricity. So there's a lot of things that need to happen, a lot of innovation, and it's you need the right structures, you need changing processes to cope with that if you have a bigger corporation. And I think one challenge to add, which we see in our daily business, is that also on the consumer side, consumers are very demanding. And with that, I mean interior continuously need to change, your exterior need to change to the new trends, to what the customer wants. They also want personalization. And if you work in the back with a very standardized production method, which is set up for mass production, you need to get that aligned with a front end which needs more versatile, more efficient offering of your cars. I think that's another big challenge.
Fair enough. And Lisa?
And now I'm jumping in, and I hope I will stay in the call. I had some trouble with my network.
We can hear you fine right now.
We're looking at this whole thing a little bit from a different perspective, coming from the desktop market. The biggest challenge that we see right now in automotive is that our customers need to be more productive on a regional base, meaning digital local manufacturing is going to be a topic more and more, especially in times of Corona. Our target group is not so much the end customer who is buying the car, so mass production, but way more the production itself. How can we an optimized production environment for the workers and the staff at the big OEMs, at the tier 1 and tier 2 suppliers? And there, of course, the challenges are keeping production up, to reduce the lead times, to reduce the, I would say, delivery times of the suppliers, and really to stay productive, make a more and safe environment for the workers in the production plant. That's the challenges that we face.
Ask a follow-up on this, Lisa. You're mentioning local production. Okay, obviously during COVID, it's tremendously helpful and beneficial. But a few months ago, where our lives were completely different to what we live right now, considering how globalization has improved over the years, wouldn't it make more sense for these massive corporations to produce in centralized facilities and then distribute from there?
Well, it depends a lot on what you're looking at, Filippos. I would say depending on the application. If we're talking about mass production, of course, mass production centralized would be better. But if you think of jigs and fixtures, which is one of the main topics in this discussion today, it is really better to have desktop printers, no matter which technology we're talking about right now, at the plants directly aside of the assembly line, for example, to print in the minute you need the part and not waiting for, I don't know, 6 to 8 weeks of delivery time for a small measurement gouge, for example. As we have faced this at one of our big OEMs, it was Volkswagen in Portugal, where one of the workers was waiting for a small measurement gouge for 8 weeks. And we decided to print it during lunchtime after designing it in 10 minutes on SolidWorks. And 2 hours later, he had that part in his hand and he could work again. This is exactly what we are focusing and targeting on.
Yeah, that's a very good advertisement of 3D printing, I think.
Yeah, and I think, Filippos, actually, that is a good point that Lisa just mentioned, is that in additive manufacturing, we always speak about the certain applications that make sense for the technology, and that's the reason why we choose this particular technology. I think maybe some of you might disagree, but in my point of view, additive manufacturing as a whole, we are not arguing here as a group that additive manufacturing is superior to any other production technology in a general perspective, and it's better than injection molding or any other kind of conventional production technology. That's not the point here. I think in automotive industry, we are looking at some very, very interesting applications, or let's say segments, where additive manufacturing can play a major, or can be leveraged in a major way, and where the advantages of additive manufacturing come really into play. And I think in those segments, it definitely makes sense. Does not say that we will turn the whole automotive production into an AM world in a couple of years. I think this is not the point.
And I think maybe to add to that as well, I think the most important thing, what we see now also as a need, is that parts need to be qualified. So we can make anything we want, but you see that the entire line, when it comes to, for instance, injection molding, everybody's used to that. All these parts, or the entire chain has been validated, and that is something still that you will work on with additive manufacturing.
Well, that's a very good point, because actually I wonder about this often, and I guess this is a great opportunity to ask. But what you mentioned earlier, Lisa, about how time can be reduced dramatically, it's a phenomenal point, and it's a unique selling point, if you may, of 3D printing in general as a technology, the fact that you can produce something as quickly. But when we're talking about an industry like automotive, and correct me if I'm wrong here, the regulations are very strict. It's very often very time-consuming to get a product approved and inserted into production of a vehicle. How do you see that going with? Okay, I can produce a part quickly, but then it can take months, if not years, for this to be incorporated in the production of a car.
Filippos, that's a very good question. And I mean, that's something that we really have to look at separate. So what we always recommend our customers is to start with the low-hanging fruits. And the low-hanging fruits, if you want to jump into additive manufacturing, are, for example, jigs and fixtures or spare parts that are not deliverable anymore or are obsolete. So let's start with this. And if you have understood what additive manufacturing can bring as a benefit and how you can adapt it into your company, then you can, of course, move forward into other regions like not spare parts, end-use parts. But I think, and Martijn and Ole can surely give some more input on this, are a big challenge, because of course you need the certification. Certifications need time, because you need them not only for the part, but for the technology, for the process, for the material. So it's a lot of work. And I also agree with Daniëlle that we have to work closer together as manufacturers and material developers to find a better way, also with Twikit, with Gregor, who's really active in this regard to push everything forward. But that's still on homework that we're working on right now. But again, start with low-hanging fruits. That's the message that I want to send.
Yeah, I think to follow up on that, we see the same and we give the same advice. Start with what you can do now. If you look at a car interior, yeah, of course it would be nice, and we see already some cases there that you print the full inner body and maybe the full dashboard. But let's start with an accessory you can click on the exterior. Let's think in configurations. Where of course, if you go into customization, that's another thing. You want to certify your part, but if your part is a little bit different each time, that's another challenge on top of the already long certification process. So then you would look into, certifying a certain template and all the changes which can be inside that template, certify it once, and then make sure that all the customization you do afterwards falls into that certification.
So you would say on top of the certification, there is an obstacle of the repeatability of the quality of the part, having the consistency.
I think that's another challenge on top of the certification process, Filippos, because with mass production, I mean, you certify something and then very consistently you will produce it. While I think all of us know that with additive manufacturing on the factory floor, that's another challenge which everyone is working on, of course.
What's very interesting to notice so far from what you've said, guys, in regards to challenges, is that there's a large variety. Like already you've mentioned, so many different sections of automotive, from the processes that Ollie was speaking about to obvious parts like jigs and fixtures, spare parts, etc., but also customization. It seems like one of our most advanced, I guess, I could say, industries is changing in on multiple levels. From your perspective, as additive manufacturing experts, how do you see things changing? Like, what would you say are the main opportunities for the big car manufacturers right now to jump into the technology, if you may? I don't know if it is the low-hanging fruits you were saying, Liz, or perhaps something else, but how do you envision companies, how do you experience companies getting into AM?
So maybe I will start answering this question. So I think what we mentioned, the different use cases we mentioned so far, is quite a good mirror for what is actually happening in the industry. So of course we see all the automotive companies already very engaged in additive manufacturing, and we also see this mix. We see the companies covering the low-hanging fruits, jigs and fixtures. I guess that is the typical business. Then you have those more niche segments like traditional cars or luxury cars, where you can actually do the first tests when it comes to end parts, or in the old-timer sector, the obsolete spare parts business, for instance. And then, of course, you also see the R&D departments working on functional parts and high performance parts, where it's about bringing new characteristics and functional qualities into parts which would be never be able to manufacture so far. So we see this mix, and I think that's the only way you actually can act as an automotive company, to dive into these different aspects, get the technology running within your company, exchange thoughts about it. You will see that all the companies, all the automotives, also have their inner circle additive manufacturing teams and meetups where they exchange thoughts and stuff like this. So I think that is a proper way to start with. But when it comes to really adoption of the technology, probably we will see step up from the low-hanging fruits to more and into customization, into spare parts, and maybe at some point in, let's say, lower quantity end parts at some point.
Yeah, and I think additionally, Ole, one topic that is really important right now is the topic electrical vehicles, right? I think something that Daniëlle also can jump in and say something about ESD safe materials that are requested more and more from our customers. how are they going to get certificates for it? As I understood from some of my customers, it's really, for each of the parts, a very expensive challenge right now to get those certified. And yeah, I think that's a big challenge that was a challenge and opportunity at the same time that we have to work on in the next months and years.
So I guess I'll jump in then. Yeah. Also what Ule mentioned indeed, and what Lisa also mentioned. So jigs and fixtures you see is the first one. Then you see it also building up to large tooling sizes where you can really start to stamp on body parts, these kind of things. But you always see that it's indeed the luxury brands, the limited amount of cars that are made that allow for these kind of technologies. And now indeed with the electrical vehicles coming up, you indeed see that flame retardancy becomes a big point, because even though you're driving your nice electric vehicle, you don't want it to set flames while you're driving it. So there comes a really specific and really big topic from the material companies, as well as the printing, as well as the software companies, to make sure that we can do this together as a complete solution to a customer. And I think an additional thing, which is maybe even a bit out of the box right now, is that you'll also see there that sustainability is kicking in. So not only the electric vehicles as a sustainable point of view, but also when it comes to, for instance, the jigs and fixtures that people are using, they use it until a certain series has been produced and then they throw it away. If you're lucky, they can collect it, they can shred it and reuse it. But that point of view also you see changing nowadays. It's really cool, I think, that at least from additive manufacturing point of view, people are aware that they don't have to make the same mistakes as injection molding has done in the past.
I think you just opened an amazing subject. You mentioned it briefly earlier, but sustainability, not just in automotive, in general, in well, all over the world, but especially in the manufacturing sector, where we've done a lot of big mistakes, in my opinion, in the past. How do you see sustainability linked to AM as automotive is changing?
Oh, sorry. Well, I guess the first thing that additive manufacturing brings is already you only technically make what you need. So that's already the first advantage, and that's okay. That's not only for automotive; that's for any technology. And well, if you look into bio-based materials, these kind of things, there are already materials that are bio-based. That are recycling is still a difficult subject, because if something is next to your turbo and it lasted for 1,000 hours, is it still the same material that you initially put in there? That's still the question. Not, therefore, recycling will be a lot more difficult. But there are bio-based materials nowadays that are already in a car. So by adopting those kind of materials, you already could make an advantage in getting a more sustainable 3D printing in automotive.
What I would like to add is, I mean, what you can definitely do, Daniëlle mentioned it already, you can avoid stock. That's point one, so you don't need that much spaces as before. And like I mentioned before, I mean, digital local manufacturing offers the chance to produce where you need it, and you don't have this big delivery routes, less logistics that you have to take, and all the stuff that you have to think of if you really produce it locally.
True, and I think it's really funny that people are generally not aware that a lot of things with additive manufacturing is digital. So you're literally just sending files over the world instead of parts. And I guess for the 3D printing industry, that's so accepted, it becomes a second know-how. You don't even think about it. But when you're explaining it to people, people go like, oh yeah, really? Oh yeah, technically I only have to send the file. And if everything has been, if you have the print profiles, if you have the design, it's all digital, and in the end you only make a part when you need it. So the chance of your first time right is so significantly higher than what used to be there, but people aren't aware of it.
Nice addition, thank you.
Indeed, sorry, my mic got stuck for a sec. So it sounds like, from what you guys are saying, it sounds like sustainability is not only a great environmental point, it's an actual business ROI point of sale for additive manufacturing in general, for production automotive. What I would like to speak a little bit more about, because I feel like we've only scratched the surface, is the future. You guys have already mentioned like a lot of amazing keywords from the electrical vehicle revolution that we're going through right now, but also autonomous driving, which seems like it's going to be the norm no matter what. And there's a lot of, like, even if we just see the data, regardless of AM or other technologies, just from an investment point of view, how companies are working their way around these new technologies, it's phenomenal to see how much they invest in them. So it would be great to get like a sneak peek, if you may, from your perspective of what automotive could look like, I don't know, 5, 10, 20 years, up to you guys.
Guys want to start? Because we girls talk too much right now.
That's a good question. Yeah, of course there will be a lot of autonomous driving, electrical cars, shared cars. I think what is important, of course, next to the shared cars, there will always be individual cars. At least that's what we think. I think if you buy a Rolls-Royce tomorrow, Filippos, you probably don't want to share it, or you want to keep it for yourself. Know what I mean? So I think there's a niche for which will always exist. But other than that, we really believe into a system which works more with configurations. Like, for example, you have an electrical battery. You have the frame of your car, which maybe you can 3D print, but it's pretty big to get to lightweight. But then you can maybe produce that at a central place globally, and then take those parts locally and finish off your cars locally to have a lot of more efficient production. And you can do that really in a more flexible way. So if something change, if a demand change in the market, or if for some reason local production is important and it's more sustainable, obviously, then you can do that more at the spot. And so I think the vision here is a little bit that you can increase revenue, you can differentiate your cars more by using individualization, customization, while on the same angle, the vision of digital transformation could be that you reduce complexity. You make some parts you make globally, and the end tweaking of the car you do more locally at ateliers, the garages, the shops. I hope that's a vision that would enroll in the future.
So I think Martin has a very strong point here. A lot of the positive aspects of the technology is probably something in the back end of the production sites. So it's more about the production processes than about the final parts. Maybe you will see in the future cars, however they might look like. I'm not sure how many of the parts will be then 3D printed. I'm pretty sure that the percentage is higher than today. But I think if we're speaking about future cars, probably the topics of autonomous driving are stronger. And like, let's say the difference compared to today is stronger in these points than in additive manufacturing. The additive manufacturing influences you won't see that much on the first, I would assume. But I also agree with Martin in the case of individualization. I think it will be in regards of very special parts. I think we are talking more about interior. Maybe we're talking about seats, that are adapted to your body. We are talking about ergonomics that might be approved. Maybe we're talking about parts that like personal parts, which you will imagine as your personal steering wheel, which you bring to a shared car or something like this. So I think we're talking about this kind of personalization maybe here, maybe also connected to collecting personal data. So I think we can enrich this personalization with the data we collect for each individual, of course, bring this closer together. But the main advantages, I confirm with Martin's first point, I think we will see more in the back of the production of the automotive companies.
Yes. I think the examples that you brought, Ole, are really nice. Like imagine driving school cars, or for disabled people cars, for example, that really need different components that the standard cars, where you can really add value today, but also in the future. And what I currently see in times of Corona, and unfortunately I have to mention this, but PPE is a really important topic. So personal protection equipment that can be provided to the staff who is working in the production area to stay safe due to the current circumstances with this disease, right? So I think we have to at least look at this for the next 1.5, 2 years. And the future that I see, or the main topics that we should focus on, are materials. And I think Daniëlle can give some outlook here. But I think with the topic material, we can really bring so much benefit into that area of automotive that we for now can't foresee already what will happen in this regard.
Yeah, I guess everybody already mentioned it a bit and a lot. For what we see for the future, indeed, materials will become a big player in this as well. In my ideal case, I would guess that instead of just looking at the body and the color of your car, you could also go like, I want to have this chassis 3D printed in metal, and therefore you can go lighter, better aerodynamics, these kind of things you can now also take along. But then going to a garage, getting these things fixed, I think that's something that's still up to the OEM. Of course, a lot of things will be in manufacturing, and indeed the getting production as smooth as possible, as quick as possible. And from a material point of view, I would say it will be a combination of metal and polymers in there, because people sometimes believe everything needs to be in polymer. No, metals are perfectly capable in doing what they should do, and we shouldn't fight over that. It's there's specific things that you can perfectly 3D print in metals, and that same thing goes for 3D printing in polymers, whether it's FFF, SLA, SLS, any material or any technology, and each one finds its place in the application that is needed for making a car.
So you do see the garage then taking care of the production of a, let's say we start with spare parts. Do you see a car owner going by the garage, and the garage doesn't need to keep stock that has been shipped to them by the other side of the world? They can just produce it there and then?
I think initially, so if you take the big OEM cars, I think if they start with this, they will start, of course, with a smaller volume, get a feel for which parts will wear down quickest, know which parts you have to redesign, or make sure that you can print them fast enough if they wear out, that you can swap them out when a car comes back to you. In the ideal case, you would go to your garage where you're currently going. I do believe that will take a bit longer, so I hope at least that initially the OEMs on a larger scale will pick it up and then slowly distribute it. But technically, yes, anything that fails, you go to a garage, they make it, put it in a car, and you're finished.
Very, very interesting. I would love to just park my car at the garage and see my part getting printed. It sounds very futuristic. Guys, considering we have 9 minutes left, I recommend we hop on into the Q&A section, which I've been checking, and it has some very interesting questions. In the meantime, for all the people watching us right now, I would highly recommend you go on the top right of your screen on the Q&A and either write your question or upvote any of the questions that are already there, because I'm not sure if we'll manage to go over them all. We'll try to do so, but if there's anything you really want to know about, this is the time. So let's start with the one with the most votes at the very top, which is, can you give us some specific examples of personalized parts produced in additive manufacturing in cars? I mean, we've covered part of this already in our conversation, but I guess if we go into the specific examples, that would be great.
I think BMW had a really nice example with their lights where you could put your name or your emoji or whatever you wanted to have on it. Labeling, I would say, is an option.
Yes, indeed. So that's the Mini Yours customized program. Additionally, you have Aston Martin, for example, in their new Zagato limited edition, which will be is already brought to the market, but which will be delivered this year. It's like a small series, very exclusive, 20 cars, very expensive, and it will include metal parts in the interior body, like around 10 metal parts. I think that's another example.
Yeah,
maybe expensive, a regular classic Mini Cooper, retrofitting it to make sure that the emissions of the car goes down so that you can use it in your daily life in the city. So that's also a custom part for a car. Maybe not with your name on it, but it do as a functional part.
What I think is very important is that I think the first thing that pops up in our heads when we're talking about customization or in customized parts is personalization. So like Lisa said, putting your name on it. Mm-hmm. I think it's getting more and more interesting if you can enrich this with a few more interesting aspects. For example, at the BMW case, we also saw different patterns, for instance, for aesthetical, let's say, individualization. Not each and every one of us is actually a designer. So, I mean, Martin and we are both companies are working in customization, and we see it's actually not that easy for an individual to design a part and to make it something meaningful that is actually better or nicer than the original manufactured parts. We had a very interesting use case with Ford in a case study where we try to combine it in the customization aspects with a functional aspect. So there it was about rim lock nuts. So the little the locks you put on your rims to protect them from being stolen, and we individualized this for each car. So you had a unique pair of lock and the key for it. And to enrich this with a little individualization aspect, we transferred the audio voice of the car driver into the geometry of the lock nut pair. So I can, if you like, I can also share a screen quickly so you have one image for this. Make that very quick. So here, I think you see it now. Yeah, so here you see it, this little the little lock, and you could individualize this. So you would speak into a little app, and that it would transfer your audio message into a curve, and that would be then the unique pattern for the individualized lock nut pair. So that's the only thing I wanted to share quickly, so you have an image in mind. But I think it's very interesting if we dive into other aspects of customization above just personalization.
People do tend to steal those. So
yeah, I'm aware.
I had to laugh about it so hard right now.
Let's move on to the next question, which is, how do you want to fight against injection molding efficiency with slow, relatively inaccurate, low number demand parts? It's hard.
I think we don't fight them.
Don't fight.
That is the point I wanted to make earlier. There will be injected molded parts in the future, and there is no way we're going to fight this. I think it's a technology that has a very high level of efficiency already gained in the last decades. So I think additive manufacturing can still improve quite a lot because we don't have that history of efficiency gaining yet. So probably there will be a little shift still where the point is actually where additive or injection molding comes into play. So we might push the border a little bit more, but it's always a question, do you go for low volume or high volume? If you go for high volume, please stick to injection molding.
I think we are a nice addition. I saw the question from Michael Sattler. Reads to you. We are an addition to what is existing in the market, injection molding. And we will never, ever compete injection molding. Never. We don't want to.
And we don't need to, because we have an additional dimension when it comes to design that you can't do with injection molding. So
like freedom, right, Daniëlle?
Yeah, each technology has its place, and I think it's already a bit say we're going to fight injection molding. I mean, we had these discussions 5 years ago, and if somebody still thinks that nowadays, I think in additive manufacturing, we're saying the wrong thing.
I think there's an obvious pattern of how we like focusing on how these technologies are complementary rather than one against the other. But it's very interesting to hear your thoughts about it as well. Your reaction from all four of you was very instant and interesting. On to the next question. Can the panel please share some experience with Class A surfaces for injection molding tools? For example, IP, experience with graining, photo, etc. I guess that means textures.
I guess you mean post-processing, right?
If I want to be honest, not 100% sure from the question.
If it's based on IP, then I guess we can't share it.
I would assume so, yes. Okay, so can the panel share some experience with Class A surfaces for injection molding tools?
Well, I mean, what we can do, of course, is we can do post-processing, and you have to look into the different additive technologies that are on the market. If you look into PolyJet from Stratasys, they already get a surface like injection molding, to be honest, or nearly like injection molding. Of course, if we talk about FDM, you will have to do some post-processing to get a nice surface quality. Yes, so a lot of topics to be discussed in this regard, I think.
Yeah, for FGF, that's the same thing. I mean, it's fairly rough, but then it's milled down, so you get the accuracy and you get the smoothness.
Yeah. It's an important challenge, indeed. It's all I can say. And of course, that's the reason of existence of companies like Dimension who are really focusing on this. And other, I think all the material companies are also focusing on some kind of post-processing. It's a very important topic, at least, to drive it forward, the acceptance of the industry.
Well, guys, I would love to go over the rest of the questions with you, but I'm afraid we don't have the time to do so. To all the people watching us right now, please do keep in mind that you can get in touch with our speakers at their tables and throughout the networking sessions. Just a reminder, and I will be sharing this in the chat box, but Twikit's table is at 412, Ultimaker is at 209, DSM it is at 702, and trinckle 3D at 615. I would like to thank you all for taking part in this. It has been very informative and educational. Thank you very, very much.
Thank you, Filippos. Thank you, guys.
Thank you.
Thank you.
Have a nice day, everyone.
Looking forward to catching up with you soon.
Bye-bye.
Cheers, guys.
Bye.
Ciao.